Second type of reactive species is carbocation. Carbon carrying positive charge, which is also called as carbonium ion. Carbonium ion also planar in nature like free radical. Carbocation is also sp2 hybridized, but these are diamagnetic in nature. Diamagnetic in nature. They too are need because they contain 6 electrons. They too are need of 2 electrons. In other way, when we will go for the solid stability, carbocation and carbon free radicals are having same stability. That we will see next. Now next point arises that what are the types of carbocation? Carbocation again are of 3 types like primary, secondary and tertiary. Whenever the carbocation linked with 3 or 2 hydrogen atoms, linked with what? 3 or 2 hydrogen atoms, they are called as primary carbocation. Whenever the carbocation linked with 1 hydrogen, they are called as secondary carbocation, and the carbocation with no hydrogen, they are called as tertiary carbocation. We know very well that carbocations are planar and they contain 6 electrons. Means that all the electron releasing group stabilizes carbocation. Stabilizes what, tell me? Carbocation. Therefore, tertiary carbocations are more stable than secondary, than primary, than methyl group. In general, we will write it as tertiary, more than secondary, than primary, than methyl carbocation. Will you able to correlate with electronic effect? Yes. Electron releasing group stabilizes carbocation, or positive inductive effect stabilizes carbocation. And another point we can say that, as we said in mesomeric effect, delocalization helps the molecule to undergo resonance, or we can say that stable. Hence, in other way we can write it as triphenyl carbocation. As I have written for free radical, same way I can write over here. Triphenyl carbocation are more stable than diphenyl carbocation, than benzyl carbocation. For above example, I can write the reason, positive inductive effect. For this example, I can write the reason, resonance. What should I write the example answer? Resonance. Due to resonance, triphenyl carbocations are more stable than diphenyl than benzylic. Now let us compare with allylic also, as we have compared in case of free radical. Let us make one more conclusion. One more conclusion will make. Till then you tell me what are the examples are there where you have observed carbocation. Already I have given the 3 examples of carbon free radical. Same way we can go with carbocation also. Therefore, when benzyl carbocation undergoes resonance more than allylic, this is allylic, then we compare with tertiary, secondary and primary, then methyl. One point I will tell you, allylic and tertiary almost they are greater or equal. Both are possible. Tertiary carbocation are equal or less than allylic. This is allylic and this is benzylic, and this is benzylic. In other way we can say that In case of carbocation, because many times, as I said earlier, that many times in the question papers, in competitive exam question papers, they have asked example by taking triphenyl, diphenyl, monophenyl, that is benzylic, allylic, tertiary, secondary, primary. With respect to, they have asked many times stability and reactivity. Always remember that more stable will be less reactive. Okay. Now, if we see the examples, have you remembered dehydration of water? Dehydration of alcohols. In second year, you are going to study this mechanism. Those are written second year exam, they will be knowing that during dehydration we are going to generate water, carbocation, leads to the formation of water, alkenes. And the second most important example, that is conversion of alkyl halide to alkene. It is dehydrohalogenation, elimination. 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 And the third, remember one thing, whenever the dehydration of alcohol takes place to alkene, RX, that is alkyl halide to alkene, and one more in the second year you are going to study one mechanism as SN1, unimolecular nucleophilic substitution reaction. In this SN1 mechanism also, we are going to generate carbocation. Let me repeat once again. Carbocation. Once carbon free radical is clear to you, carbocation are not so difficult. Yes or no? Not so difficult to understand. So carbocation, where the carbon are carrying positive charge, these are containing 6 electrons. They are positively charged species, but the thing is that they are diamagnetic in nature. When we are saying that they are the need of 2 electrons to become octet, then pakka they need electron releasing group to make themselves as stable. That's why we said 2 important points. One point that electron releasing group stabilizes carbocation. Second point, what I said, that resonance will make the carbocation to be stable. That's why we have written the example like phenyl, triphenyl, diphenyl, benzylic. Same way we have compared tertiary, secondary, primary. If we write all together, we can write it as benzylic more than allylic. But this point you need to remember that especially in case of carbocation, allylic is more or equal to tertiary carbocation, secondary carbocation, primary and methyl. These 3 examples, second example, first year children already they have studied in first year. But these 2 examples you are going to study in second year. That is dehydration of alcohols by using concentrated sulfuric acid. Alcohols on dehydration, intermediate will be carbocation, final product is alkenes. Same way alkyl halide with the nucleophile. When it is a tertiary alkyl halide, the mechanism will be followed via carbocation. All this we are going to study in the second year. The last reactive species is carbanion. Carbon anion. What does it mean? Carbon carrying negative charge. Very simple to remember. Because earlier we said carbon with odd number of electrons are carbon free radical. Carbon with positively charged are carbocation. Carbon with negatively charged, they are carbanion. We can call it as carbanion. Okay. Carbon with negative charge. Carbon with what, tell me? Negative charge. They contain 8 electrons. They are sp3 hybridized. What? sp3 hybridized. In case of carbon free radical and carbocation, sp2 hybridized, but carbanion is sp3. Have you observed that many of the things are similar? Many of the properties, many of the nature are similar in carbocation and carbon free radical, easy to reproduce in the exam. Carbanion is exactly reverse of carbocation. I need not to say once again the classification. They are classified as primary, secondary and tertiary. Carbanion carrying 3 hydrogen, carbanion carrying 2 hydrogen are primary. And what tell me? Primary. Then carbanion with single hydrogen are secondary. Carbanion with no hydrogen at all, these are tertiary. Carbanion, they themselves are electron rich. It means that in case of carbanion, electron withdrawing group stabilizes. What my sentence? Stabilizes carbanion. Electron withdrawing group means which inductive effect? Very good, negative inductive effect. Positive inductive effect for both carbocation and carbon free radical. For electron withdrawing group, that is negative inductive effect stabilizes carbanion. But one thing common in all the three, that what is common in all the three? Resonance. Here also same point. Resonance stabilizes carbanion. Stabilizes what, tell me? Carbanion. Therefore, together we can write. Electron withdrawing group stabilizes carbanion. So, how you are going to write stability in case of primary, secondary, tertiary? Will you think? Exactly reverse of carbocation. Because primary will be more stable than secondary, than tertiary. Carbanion. Yes or no? Exactly ulta. Exactly reverse of carbocation. Whereas in case of resonance already seen. Triphenyl carbanion are more than, what tell me? Diphenyl carbanion. Than what tell me? Benzyl carbanion. This reason is resonance. This reason is negative inductive effect. Negative inductive effect. Same way as we have clubbed in the earlier examples, earlier reactive intermediate, same way we'll club over here. We can write it as benzyl carbanion more stable than allyl. Then what shall we? Then what? Primary, secondary, tertiary, then methyl. Carbanion, not so difficult to remember because I am writing all the point, most of the point, exactly reverse of carbocation. Now the question arises, where we have discussed, where to study. All the examples are in second year, not in first year. First example is Kenizerose reaction. Have you remembered second year children? What is Kenizerose reaction? Aldehyde which do not contain alpha hydrogen atom will undergo simultaneous oxidation and reduction in presence of strong alkali is called as Kenizerose reaction. And the second example, Perkins reaction. When benzaldehyde treated with acetic anhydride in presence of sodium acetate will produce cinnamaldehyde or cinnamic acid. Second year children may remember. And the third last example is aldol condensation. What a aldol condensation. Remember second year children, aldol condensation, the aldehyde which contain alpha hydrogen atom. Kenizerose reaction, the aldehyde which do not contain alpha hydrogen atom. All these three are second year examples. The children, those who have written the exam for the second year, they are knowing it. And first year children, in future we are going to study about these mechanisms. Because if I am going to take this mechanism also, you can't understand without knowing their base. That's why in the second year regular topic when we will start, that time we will study. The last bit of our syllabus is nature of attacking species.